Alright, let's dive straight into some AQA GCSE Chemistry revision. We are tackling a really important bit today, section 4.5.2, all about chemical cells and fuel cells. I mean, have you ever actually stopped to think about how your phone battery works? Well, it's all about turning chemicals into electricity, and we're going to break down exactly how that happens.
Seriously, think about it for a sec. The phone you're probably holding, the remote for your TV, they're all powered by batteries, right? But what's actually going on inside that little power pack? Well, it is pure, awesome chemistry. And you know what? Getting your head around this is absolutely key to nailing this part of your exam.
Okay, so here's our game plan. First up, we're going to cover the absolute basics, how to make electricity with chemicals. Then, we'll look at the two different types of batteries. After that, we'll get into something a bit more futuristic, hydrogen fuel cells. And importantly, we'll compare them directly with batteries, which is a classic exam question. And to wrap it all up, we'll have a super clear exam checklist, so you know exactly what you need to remember.
Okay, let's jump into our first section, making electricity with chemicals. Now, this stuff is the foundation for everything else we're going to talk about, so it's really important to get this locked in. So, first things first, what even is a chemical cell? Well, at its heart, it's just a really clever system where a chemical reaction happens, and that reaction directly produces electricity. No moving parts, no generators, just pure energy straight from the chemicals reacting. It's a super fundamental idea, so make sure you've got this one down. And believe it or not, you could actually make a simple one. The recipe is pretty easy. Step 1, you take two different metals, and that's the key word there, different. They're going to act as your electrodes. Step 2, you pop them into a solution called an electrolyte. And step 3, you connect them up. A chemical reaction kicks off, and voila, you've got yourself an electrical current. So, what about the amount of power you get? Well, the voltage, that's the electrical push, isn't just random. It all comes down to your ingredients. You use different metals, you get a different voltage. You change the electrolyte, guess what? You get a different voltage. And here is a massive exam tip for you. The bigger the difference in reactivity between the two metals you choose, the bigger the voltage you're going to get. Remember that one.
Okay, let's move on. Now we know what a cell is, let's talk about batteries and the two main types. And this brings us to a question you've probably wondered about before. Why is it that you can recharge your phone over and over, but the battery in your TV remote just dies and you have to throw it out?
Right, before we go any further, just a quick bit of exam precision here. In everyday life, we kind of use the word cell and battery interchangeably, right? But in chemistry, there's a difference. A single unit is a cell. A battery is technically when you have two or more of those cells connected together to get a bigger voltage. Think about a car battery, it's not one big cell, it's actually 6 smaller cells all linked up to give you that power.
So, back to our question. The huge difference between non-rechargeable and rechargeable all comes down to the chemical reaction. In a non-rechargeable one, the reaction is a one-way street. The chemicals react, they make electricity, and eventually they get used up. Game over. But in a rechargeable cell, the magic happens. The chemical reaction is reversible. So when you plug your phone in, you're sending in electricity to force that reaction to go backwards, turning the products back into the original chemicals. It's basically resetting the whole thing, ready to go again.
Okay, so we've got a good grip on normal batteries. Let's look at something a little bit different now. Something you'll definitely see in your exam. Hydrogen fuel cells. This isn't just theory either. This is a huge area of research for things like cars and buses.
So, a fuel cell, it's still making electricity from a chemical reaction, but there is one absolutely massive difference. With a battery, all the chemicals, the fuel, is sealed inside. A fuel cell is different. The fuel, like hydrogen, is fed in from the outside, constantly. As long as you keep giving it fuel and oxygen, it'll just keep on making electricity. It never runs flat in the same way a battery does.
And this brings us to the biggest selling point for hydrogen fuel cells. The overall reaction is incredibly clean. You've got hydrogen reacting with oxygen, and the only thing that comes out the other end is water. Yep, just pure water. No nasty pollutants, no carbon dioxide. This is a massive plus point and a key fact you need to have ready for the exam.
All right, here we go. This next bit is one of the most important parts of the topic, especially for your exam. It's the big comparison. Fuel cells versus batteries. Examiners absolutely love asking you to weigh up the pros and cons of these things, so let's make sure we've got it straight. Okay, let's break this down. With a rechargeable battery, right, all the chemicals are stuck inside. To re-energize it, you have to charge it, which can take a long time. Now compare that to a hydrogen fuel cell. The fuel comes from the outside. So to re-energize it, you don't charge it, you just refuel it. which is way faster. And remember, with the battery, the products of the reaction stay inside. With the fuel cell, the product, water, just leaves as waste.
Okay, quick heads up. This one is specifically for all you higher-tier students out there. Listen up. For you guys, it's not quite enough to just know the overall reaction. You have to know the half equations for what's happening at each electrode inside that hydrogen fuel cell. You've got to be able to write them out, so please make sure you go and revise those specific equations. It's a must-know.
Whew, we have covered a lot of ground there pretty quickly. So, to finish up, let's pull it all together with a super clear checklist. This is basically what you need to be able to do by the time you walk into that exam.
So here it is. Number 1, you need to be able to talk about why we use certain cells, and specifically how the reactivity of the metals changes the voltage. Number 2, you've got to be able to compare fuel cells and rechargeable batteries, the good, the bad, the whole lot. And finally, that extra one for higher tier only, you must be able to write out those half equations. If you can confidently tick off these skills, you're in a really good spot for this topic.
Hey, just to leave you with a final thought, this isn't just some abstract stuff for an exam, you know? The science we've just been over is at the very center of a massive global question. What's going to power our world in the future? Will it be better and better batteries, or will fuel cells take over? Understanding the chemistry is the first step to figuring that out. Okay, that's it from me. Best of luck with your revision.